As we continue talking about volume today, we're going to get into volume of pyramids and cones. We talked about prisms and cylinders last time, so now we'll get to the pointy things. How do we calculate that volume? I wonder how. Well, let's figure it out. So if I were to take a prism, and let's say we have a square prism, and let's fill this thing up with sand. Let's pretend we're doing that the same height as this pyramid. And then I fill up the pyramid with sand. How much smaller will the volume be? Well, it's been proven that, and I won't go through the exact proof of that. I'll assume that you're going to trust me since I'm your math teacher. But it's going to be a third smaller. If I were to fill this pyramid up with sand and then dump it into this prism of the same height, it's going to fill up a third of the height. So in order to find the volume of a pyramid, I just do the same thing I did for the pyramid, area of the base times the height. We're going to divide it by 3. The same will work with a cone. If I fill a cone up with sand and pour it into a cylinder of the same height, it could be water even, or anything else you want, it's going to fill up that cylinder a third of the way. So area of base times height divided by 3. And in the case of a cone, the area of the base is a circle. So it's going to be pi r squared times height divided by 3. Let's use that in our work today. So let's take a look at Khafre's pyramid in Egypt. Maybe some of you are some history buffs and know all about that and can tell me all about who's buried in Khafre's pyramid and all that other good stuff. But we're just going to calculate the side length of a square base. So we're going to apply the volume formula. Volume equals area of base times height divided by 3. So the pyramid had a height of 144 meters, and the volume was 2,226,450 cubic meters. So now it's a matter of filling in the formula. So volume is 2,226,450. Area of the base. Well, what is the base shape? The base is well, we're going to assume that it's a rectangle. The Egyptian pyramids were rectangular bases, so the area of the base is side times side, side squared, times the height, which is 144, divided by 3. Then it's just a matter of solving the equation. And you know how to do that, I hope, I'm assuming. So let's just go through how to solve that. So multiply both sides by 3. And now we're going to get a larger number, 226. So now we get 6679350 equals side squared times 144. So now I'm going to divide by 144 to try to get s by itself, which will give us a smaller number now. 46384.375 equals s squared. And then it's just a matter of taking the square root to cancel out our square. So the side will be the square root of that, which is approximately 215.4. And we're talking in meters. So the side length of that pyramid would be about 215.4 meters. That's a big pyramid. I guess you could do some research and figure out if we are actually correct or not, and figure out maybe even if which is that, can't talk, which is the biggest pyramid. How does this rank? But that's a history lesson, so we won't do that. Let's take a look now at these. Let's see if you can calculate the volumes of the hexagonal pyramid and the right cone. And if you remember last time, we kind of worked on calculating this area of this hexagon. This time we're only given length 4. So I'm going to let you see if you can figure out how to calculate this area when you're only given the side length. So good luck. Pause the video, restart when you're ready. Okay, so we got to do a little bit of work to figure out this hexagonal pyramid. So if we take a look at this hexagonal pyramid, I can break it up to equilateral triangles, and they're 60 degrees each. So if I take a look at this triangle, I know that, let's just highlight this area here. If I take this triangle here and move it outside, I know that each side will be 4. And if I split it in half, 30, 60, 90 triangle, 4, this will be half of that. So times square root of 3. So multiple ways I could do that: use my trig, use Pythagorean theorem, or what I used was my knowledge of special right triangles to help me with that. But I could also figure out that these are 60 degrees each because this is a 6-sided figure. Remember, the number of sides minus 2 is 4 times 180 means there are 720 degrees total in this figure. If I divide that by 6, I know that each angle is 120. So each of these are 120. So if I split those each in half, they're each 60. So that's how I get that. So then I need to find the volume or the area of that base. So that's 6 triangles times each triangle's base is 4 times the height of 2 square roots of 3 divided by 2 times the height of the figure, which is 11. Divide that by 3 since it is a hexagonal pyramid. Next, for the right cone, I realize I've done something wrong right now, but I'll come back to that. In my right cone, I need area of base times height. Since it's a circle, the base is pi r squared times the height of the figure. So the height of the figure I'm not given. This is the slant height. So I took this right triangle and used that to find h using Pythagorean theorem. So h is square root of 39. So maybe you've seen what I've done wrong already, and maybe you're ready to correct what I did. But what have I forgotten? Well, since it is a cone, I need to divide it by 3. So let's fix that in our equation. Divide by 3. And let's go through and fix all these. So my answer isn't totally right yet. I need to divide everything by 3, which I need to go back and fix. So this is not right. I need to take 490.5, divide that by 3 to get approximately 163.5. That looks better. But the big thing here is we got to make sure that we find out what we need to know in order to find the area of the base and the height. So in the next problem, suggests that we use some trigonometry. So why don't you pause the video, see if you can find the volume of this right cone. When you're ready to see an explanation, whether it's correct or incorrect, you will see. So restart the video when you're ready. So you got to review your trig, your SOHCAHTOA, in order to help you figure this one out. So if we take our right triangle from this cone, as we think of our cross section as we view it from the side, it's a triangle. We can pull that out. Now the height is 12, and this angle is 62. We need to find r. So this is my opposite side, this is my adjacent side. O and A, so I'm using TOA. So tangent of 62 equals opposite over adjacent. And then I solve for r, I get r is 6.4. So then I use that to find the volume of the cone, so area of the base times the height divided by 3. Well, the base shape is a circle, so that's pi r squared times the height divided by 3. Simplify it, 163.84 times pi, which is approximately 514.7 meters cubed. So that finishes up talking about volumes of cones and pyramids. The big thing to remember is, think of it in terms of the prisms. think of the prism. Find the volume of the prism, then divide it by 3. And you'll be all set. So next time we'll talk about volume and surface area of spheres.